to do, circle that multiplication sign. Trust me, circle the multiplication sign. Write the word of above it. And I need you to be with me, okay? All right, so whenever you see a fraction times a whole number, or a whole number in front times a fraction, you can substitute the word of for the multiplication sign. Now, why is this important? Because you're going to get a problem, and I'll tell you a word problem here in a minute, but let's practice this. So in Module 4, here's the first way they teach it to you, okay? So this could be half of 12, which we already know is 6, don't we? So draw a tape diagram right there, please. Okay? Do I have a total? 12. Okay. What's my denominator?
2.
So I need 2 equal parts. What number goes in the box?
6.
And that's how I write my answer. Kind of clever, isn't it? So 1/2 of 12 equals 6. And I just showed it with the tape diagram, okay? That's the first few lessons. Then we move on and just do it with numbers. Okay, you ready for this? So we would do 1 times 12 divided by 2. Now, why am I dividing by 2? Because that's my denominator. By the way, when you take anything times 1/2, you just divide it in half. Okay? You guys remember that? If I take a number smaller than 1 whole times a number, it's really like we're dividing. Okay? All right, so 1/2 of 12. What's 1 times 12? And 2. Look at the board. 12 divided by 2 equals. So I know my answer is going to be 6 down here too. So we do that for a few lessons, okay? And then they make it even more complicated. They want us to simplify it to start with. This is fun. So I'm going to do 1 times 12 divided by 2. Write that again. You with me? Okay. I'm going to simplify this to start with. What can I divide both of these by? 2. So I'm going to do it in my head. So cross them off. This is how you write it. So I'm going to do 2 divided by 2. What is it? Just write it down there. 12 divided by 2. What is it? And so now I have 1 times 6 equals 6. And do I ever have to write a 1 under the number? Only if I want to turn it into a fraction. And I don't want this to be a fraction. So my answer is 6. Okay, let's do another. I really think this is kind of fun. So this one is 1/4 of 16, or 16 times 1/4. So get yourself a tape diagram. Okay, what's my total, Logan?
16.
16. What's my denominator? What is it?
4.
4. So I need 4 equal parts in my tape diagram. Now, do you know what number goes in the box?
Yes, 4.
4. So
4
put
times
4 in the
equals
box.
16.
Yeah. So 1/4 equals what? 4. So my answer is going to be 4 when I get these problems done. This is pretty easy to understand, isn't it? In fact, we did something kind of like this. So now I'm going to write 16 times 1 divided by 4. Okay, 16 times 1 divided by 4. What's 16 divided by 4? 4. Now we'll do it a more sophisticated way, don't you think? Okay. So I still set this up the same way. 16 times 1 divided by 4. But I'm going to simplify it. So what can I divide both of these by? 2, but I think I could go higher than 2.
4.
4. So what's 4 divided by 4? What's 16 divided by 4?
4.
So now I'm going to do 4 times 1 over 1, which I don't have to write that 1. So it's 4. Clever, huh? Okay, let's do another. This one's better. This one, I'm going to give you a word problem to represent this one here in just a minute.
It says on your personal whiteboard.
Yeah, well, I don't do personal whiteboards. There's a couple reasons. Number one, they're too messy. We get black stuff all over the tables. Number two, it takes too long for kids to copy this down when I could just have it in front of you. So draw a tape diagram, and I'm going to give you a word problem for this, okay? All right. So Bella, no, I'm going to change that. Grant. Grant went to the arcade with $16. He spent 3/4 of his money on the dancing disco squares. Just kidding. That's my granddaughter's favorite thing at the arcade. Okay, can you see why? Don't you just have to hop on the ones that light up or whatever? Okay, so how much money does Grant have left? That's the question. Okay, so
Mrs. Lewis?
So where will I put 16 on this tape diagram? Okay. And my denominator is what? 4. So I'm setting this one up very similar to the last one. What's the only difference? There's 3. So 3/4 equals 12. But that's not even the answer to my question. How much money does Grant have left? 1/4? How much money is that? 4 what? $4. Okay? So that's the kind of question you're going to get. He spent 3/4 of his money. 3/4 of 16 is 3/4 times 16. Are you following me? Okay, let's solve it numerically. 16 times 3 divided by 4. Okay, if you want to do standard algorithm, go ahead. Some of you don't need to. You can just do it in your head because you're that good. I was never that good. Did you get 48?
Yeah.
48 divided by 4. Ooh, I bet it's 12. Is it?
Yeah.
It is. Okay. All right. Now, on the test, you know what they're going to give you as an answer? Choice 12. But we already figured out how much money he has left. $4. So do you have to read carefully to be smarter than that person that wrote the test questions? Yes, you do. Did I say they were evil?
Yes.
One time I did. This way's better because I get to simplify ahead of time. So when I simplify, do my numbers get smaller?
Yes.
Are smaller numbers easier to work with? Yes. All right, so what can I divide both of these by? I think we just did it, didn't we? What's 4 divided by 4? 16 divided by 4? Okay, so 4 times 3 equals... Now, I want to show you something. Everybody write 16/4 down. Okay, just do it. Trust me. So if I were going to have you simplify this, would I write it like this?
No.
Yeah, I would.
Yay.
When you simplify, don't you divide the top and the bottom by the exact same number?
Yeah.
Yeah. Well, that's actually what I'm doing here. I'm just writing it differently. But wouldn't I get a 4 over a 1 when I simplify this? Is that what I have here?
Yes.
A 4 over a 1? I do. Okay? So it's really the same as simplifying, isn't it? Okay, let's look at this one. I think you have to turn the page. Okay. Now, do you want to try this on your own?
Yeah.
I think you do. Okay, so we're going to get a total. And you've got a denominator. What is it? Okay, try and solve this on your own. I'm going to pause it. Okay, because I don't want to run behind, I'm going to go ahead and rush you a little bit. So, Jackson, do you know how many equal parts I need in this tape diagram? 3. Jackson, do you know what number goes in each one?
3.
So 9 divided by 3 equals 3, correct? Okay, so Kevin, I should put a bracket around how many of these 3s? Huh? 2 of them, because that's my numerator, okay? So 2/3 equals what number, boys and girls? 6, okay? All right, so tell me what to write. Brendan, tell me what to write right here.
2 times 9 divided by 3.
Good. What's 2 times 9?
18.
Divided by 3, what's the answer?
6.
Is that what I got here? Okay. So the next one, 2 times 9 divided by 3. Alex, what should I cross off?
The 2 and the 3.
Okay, good try.
Okay, the 3 and the 9.
The 2 and the 3 won't divide into each other, will they? So I have to do the 3 and the 9. Can I simplify this?
Yep.
Sure. What am I going to divide them both by? 3. What's 3 divided by 3?
1.
What's 9 divided by 3? 2 times 3 equals...
6.
Okay, this next one's a little harder. But let's start with the tape diagram, okay? What's my total here? 24. What's my denominator? 6, the number on bottom. Denominator downstairs, remember? Okay. What's my numerator? 5. So that's how many you bracket. Okay. Now, to solve this, I'm going to do 24 divided by however many boxes I have. So 24 divided by what? 6. So what goes in each box? 24 divided by 6. So 5/6 of 24 equals 20. All right, so now we're going to do 24 times 5 divided by 6. This is not the easiest way because I have to do standard algorithm, right? So anybody know what 24 times 5 is? 120. We did it earlier, okay? So 120 divided by 6. Can't I just take this 0 off and then put it back on? Okay, so if I do 12 divided by 6, what do I get?
2.
And then add a 0.
20.
Is that what I got over here?
Yes.
Okay. This one,
24.
yours says 23. It's a typo. Just fix it. I was going too fast, I guess. Okay. So can I divide these both by
6.
for you? This says find the area. All right. Now, if these words were not up here at the top, how would I know this was an area question? And I want you to raise your hand. Chloe, how would I know?
Because it has the numbers on the top.
Okay, it has a number on 2 sides of the shape. Wrong. Okay, good try though. Guess what the kids in last block said? The same thing you did. Okay? All right? Cadence, how would I know it's an area question? You're getting closer, but not correct yet. Jesus.
The shape?
No. No. Lexi.
The multiplication sign?
Okay, the kids in the last block said the multiplication sign. That's wrong too, but it's close. Okay, now listen, because put your hands down, I'm going to teach you something here, or remind you something. If this were a perimeter question, there could be a multiplication sign in it. Remember, perimeter is all the way around the shape, so it could be 2 times 2 plus 4. That could be the perimeter formula. So there's a multiplication sign. So you can't always just look at the multiplication sign, can you? Okay? So we would add up 8 and then 16 would be our perimeter, okay? So let's keep thinking here. Let's keep thinking. Emily,
The 2 at the end.
you got it. It's the 2 at the end. What does that 2 mean?
Times 2.
No,
Square.
square. That means inches squared or square inches. And that's the only way I can know for sure it's an area problem. You might get a word problem and you got something squared in there and you need to be thinking about the formula for area. What's the formula for area?
Length times width.
Length times width, okay? So L times W equals area. Write that at the top of your notebook paper. And we always answer in inches squared or square inches. The 2 means squared, and it saves us some time, doesn't it? Okay, so what I want you to do is I would like for you to, on your notebook paper, write down this entire multiplication sentence with labels and the answer. On the inches squared, can you look up here for just a minute before you do? It should be, the 2 should be smaller. I guess I forgot to do that when I made the file, okay? But the 2 is typically smaller and it's a little bit raised, just like an exponent, okay? But it means squared. All right, so let's just write down the first one so we make sure everyone knows how to do area. I think you do, okay? So you're going to put 2 inches times 4 inches equals 8 inches squared, okay? So does it matter the order I put the numbers? No, because commutative property of multiplication, okay? So what I want you to do on your notebook paper now is get busy writing the answers for the rest of these, and I'm going to pull sticks so kids can come up and write them, okay? Use nice handwriting because we are recording. Abdiel, you're first. This is kind of a trick because they only gave you one side, but it's a square. So I'll help you through it. Come on. So what would this side be? Okay. Okay, very good. We'll pull another stick. Eurydia, you come up. After Eurydia is Josue. We'll keep this moving a little faster. You guys should be writing on your papers as we're writing on the board. For me, you're after Josue. Come up here and get in line. George V, you're after for me. Good. Good. Thank you. Okay, check your answers with theirs. Boys and girls, when you write on the board, if you will stand with your shadow over here to the left of where you're writing, then your head won't get in the way. Does that make sense? Okay. All right, that's a 6. You can't read it, it's a 6. Okay, you understand what you're doing? Yeah. All right, that's a review of 4th grade. Some of you might have been confused when you learned that, and you were confused between perimeter and area, and we're going to practice both of those in the future, okay? All right. You got them? Okay, let's take a look at the lesson for today. Now, when we do this lesson, it's very important that you follow directions specifically, okay? So right now you need a colored pencil. Okay, the first direction I want to give you is, I want you to shade in 4 squares in the shape of a square with your colored pencil.
Maybe anywhere?
Yes. We're not going to use this page very much, so you can put it anywhere on the page. Okay, so you've got 4 and they're shaded somewhat similar to mine. Okay? This is called a base. When we're talking about 3-dimensional figures, 3-dimensional figures have a base. And we'll talk more about bases later, because your base is going to end up being part of your formula for volume eventually, okay? So how many of you remember the formula for volume that Mrs. Hager gave you?
Perimeter.
No, volume. No?
No.
Okay, raise your hand if you've got it. You think you got it, Chloe?
Oh, that's high.
You got it. Length times width times height equals volume. Write that on the top of your paper. Okay, so there's area inside of this, isn't there?
Yes.
Yeah, length times width is area. Okay, so eventually your problems are going to say the area of the base is 8 centimeters squared and the height is 6 centimeters. What's the volume? And you're going to have to know what to do. So all I'm teaching you today is what the base is. It's the bottom of your figure or your structure that you're getting ready to build. Okay? Now what I want you to do is to take 4 cubes and make the first floor of your structure. It's going to be kind of like a building with more than one story. Okay? So you're just going to take 4 cubes. Please don't waste time making a pattern. Just pick up 4 cubes and put them right on top of your base. Bless you. Mine kind of overlap, but that's the best I can do, okay? All right, so you got it? What's the volume of this?
Two.
Oh, wait a minute, not the formula, just the volume. How many cubes did you use? 4. So my volume, and you can write this over to the side or anywhere. My volume is 4 cubic, and we're going to call it centimeters because we know these are centimeter cubes and this is centimeter paper. But if we didn't know it was centimeters, we would say units. 4 cubic units, okay? Another way to write it is 4 centimeters. How do you think I make the cube?
2.
Good try.
3.
A 3, okay? So this is your introduction. Did you write this on your paper? You can write, I want you to write it both ways, cubic centimeters and centimeters cubed. Okay, so let's add another floor to this structure, okay? So please don't worry about the pattern, just put 4 more cubes on there. Okay, what would the volume of the structure be now, Jesus? What did he say?
8.
He did. Okay, so instead of 4, it's going to be 8 cubic centimeters or 8 centimeters cubed. Okay, we're not going to worry about the formula right now. So now, let's do, what do you think? One more floor? I guess so, since I have 3 colors of cubes here.
Yep.
Okay? So add one more floor, so this would be the third floor of your structure. Once you get that on there, how many cubes are in the structure now? Okay, so I'm going to give you a word. It's a geometry word. Okay? And this only works if the base is the same as the top. Remember what the base looked like? Do you remember? You could even slide your cubes over, couldn't you? And look at what the base looks like. Is the top of the structure the exact same size and shape as the base?
Yes.
So we will call this, and you've probably heard it before. Don't read it yet because it's going to take me a minute to write it. What's that? What are those? Okay, so this is an example of a rectangular prism. If I were to take one of these cubes off, whoops, that was my base. Let me try that again. This isn't going very well, is it? Let me try it again.
You can just move your base over.
I think I'm just going to move my base over.
Or you can push that
No,
X.
okay, let's just say I take this cube off and I don't have it up there. Is it still a rectangular prism? No, why not?
Because
The top is not the same shape and size as the bottom, okay? Got that? All right, we're going to go on to the next problem. Now, the next problem I didn't put on here, but I just want you to count out 12 cubes. Okay? And this has nothing to do with the square we just did. You can't use the square we just did. Okay? So do you have 12 cubes?
Yeah.
Okay. And the shape we just made, the rectangular prism we just made, is off limits. Okay? I want you to make another rectangular prism with 12 cubes. The easiest way to do it is to color in your base. Okay? So I'm going to give you an example of one way to color in a base for this. I could use three cubes on the base and create a rectangular prism with 12 cubes in it. Okay? All right, you want another idea? I could use 6 cubes on the base and create a rectangular prism with 12 cubes. Okay? Those are a couple of ideas for you. I'm sure you could come up with your own ideas. Okay? You can color in the base if you want, or you can just start building. But I need you to build as many rectangular prisms containing 12 cubes as you can that are different from each other. And it has to have 12. I'm going to set the timer for 3 minutes. Problem 3, you don't need your cubes for. You can just slide them back and turn your paper over. Do it now. So problem 3 is teaching you how to draw cubes on the dot paper. This is called isometric dot paper. I never even heard that word before I started teaching this lesson, okay? Now, we are going to use the paper later on in the lesson to solve a problem. So save room at the bottom, okay? We're going to start with 1 cube, and there is a method to drawing cubes like this. So you have to follow the steps in order, okay? The first step in drawing cubes like this is to connect 4 dots to make a parallelogram. So with your pencil, connect 4 dots to make a parallelogram. Okay? Once you have the parallelogram made, put your pencil down, just so I know it's time to go on. Because kids would have their heads down looking and then they wouldn't see the next step. Okay? All right. Then you draw lines connecting the dots right behind the parallelogram. Okay? When you have that step done, please put your pencil down. Include your colored pencil too. Okay? Thank you. And then you connect the back side. And that makes your cube. Okay, what's the volume of this figure?
5. 1 cubic.
1 cubic centimeter. Very good. 1 cubic centimeter or 1 centimeter cubed. Okay? All right. So the next figure we're going to draw is 2 cubic centimeters. Watch me first. So where should your pencil be? Thank you. Okay. So you're going to connect 4 dots to make a parallelogram. 2 sets of parallel sides, and if you look at it sideways, it kind of looks like a kite. Okay? Wait a minute. You're going to connect another parallelogram to that one. Okay? Did you notice I don't start way at the top? Because I might need that room to draw. So I move it down a little from the top. Okay? Now this next step I call go back, because it kind of looks like it's going to draw the back of the cube that we can't see. Okay? So when I say draw your lines back, I really sort of mean to the right, don't I?
Yeah.
Okay? All right. You got that much done? Put your pencil down. You went the wrong way with your back. Okay, so there's one thing I forgot to say. Don't turn your paper on its side. My paper is straight, vertical in front of you. In order for you to draw it like I did, keep your paper vertical in front of you, okay? And then that will keep you from getting mixed up. So you're going to go here, here, here. Okay. So then you can connect the back side of the cubes that we can't see. Dara, what's the volume of this figure? To what? Huh? Help her, Cheney. Cubic centimeters. Very good. Thanks for raising your hands. 2 cubic centimeters or 2 centimeters cubed. Okay? You want to try 3?
Yes.
Okay.
Yes.
So I'm going to, hey, let's do 3 a different way. Let's stack the parallelograms. So I'm going to do 1 parallelogram. Okay? I'm going to stack one either on top or on bottom of that one. Don't turn your paper sideways. That will be a lot easier. Okay? Then I'm going to stack another one on top of that parallelogram. Okay? Now watch. I'm going toward the back of the cubes next. You're getting this, aren't you?
Yes.
Okay. Then you connect the edge that shows the back side, sort of. You have to visualize it, don't you? Okay. What's the volume of this structure, Lexi? These are centimeters, aren't they? Another way to say it, George A?
3 cubed
3 centimeters cubed. Good. Okay? So that's a little introduction. How will length times width times height play into this? Let's start on the 1 and 2. Okay? So this one in front we're going to call your length. Okay? Put your L there. The one going toward the back we'll call the width. And the height is how tall it is from the bottom to the top. Okay? So if I'm going to plug in numbers for each of these letters, what number would I use for the L? 2. So that's going to be 2 centimeters times. What number would I use for the W? 1 centimeter times. What number would I use for the H? 1 centimeter. And that equals 2 centimeters cubed. So write that down. I'm not writing it just for myself. And it looks to me like I should have centered it a little better. No. 2 times 1 is 2. And 2 times 1 is 2. Don't accidentally add. Okay, so the next one. This right here would be your length. Your L's right here. This would be your width. And your height would be on the side. Doesn't matter which side. Okay? So let's plug numbers into these letters. What is the length? 1 centimeter times, what is the width?
1.
And don't forget your labels. Times, what is the height?
3.
Hopefully my board will catch up with me. Equals 3 centimeters cubed. Okay, kind of have the idea?
Yeah.
All right, you're ready for a problem. We'll come back to this paper though, don't worry. Okay? Plus, you can take it with you. You don't have to put it in this order unless you just want to. Okay, so how much time do we have? Enough. Okay, so here's a problem for you. Put your pencils down, Beverly. Put your pencil down. Draw later, okay? You're not going to use a pencil to solve this problem. Don't worry about it right now. I'm recording. Why would you even ask that question, okay? So Jackie and Ron both have 12 centimeter cubes. Jackie builds a tower 6 cubes high and 2 cubes wide. Ron builds one 6 cubes long and 2 cubes wide. I notice they're both 2 cubes wide.
Yeah.
Okay? Jackie's is 6 cubes high, so that goes up. And Ron's is 6 cubes long, so that goes across. Okay? Jackie says her structure has the greater volume because it's taller. Ron says that the structures have the same volume. Who is correct? Ron. Definitely. Because they both started with how many cubes? 12. So do they have the same volume?
Yes.
What is the volume? 12 cubic centimeters. Okay? So we know Ron's correct. We're going to draw a picture to explain how you know. But before you draw a picture, let's just take 2 groups of 12, build Jackie's, and then build Ron's. Okay? All right. So on Jackie's, you're going to go 6 high and 2 wide. Get 6 cubes and do, or 12 cubes and do that. And then on Ron's, you'll go 6 cubes long and 2 cubes wide. And then I got a picture to show you the correct answer in a minute. Okay, so let's take a look at the way the drawings will look when we're done. Okay, so Jackie's is kind of like a tower, isn't it?
Yep.
Okay. Ron's is more like Walmart or a strip mall, okay? This one would have an elevator, this one would not, right?
Yeah.
Okay, so let's go back to your dot paper and with the next 4 minutes, let's try and draw these. I'm going to help you, okay? So back we go to the dot paper. So let's start with the tall one. How tall was it? 6. So you're going to stack 6 parallelograms on top of each other. Don't try and cut corners by drawing lines because it's not going to work. So you've got your 6 parallelograms. 1, 2, 3, 4, 5, 6. How wide is it?
2.
So I have to go back 2 dots. That one was pretty crooked. There we go. Okay, so I heard some of your pencils go down, good. Then you're going to connect the middle before you connect the back. So that's Jackie's, correct?
Yeah.
Here's the length, here's the width, here's the height. Okay? So this would be 6 times, what's the width? 2. I mean 1 times 2 times 6, sorry. Okay? Does that equal 12?
Yeah.
Okay. We're only not writing it because we want to draw the next one. Okay? This one, you'll put your parallelograms next to each other. So they're going to go diagonal across your paper. You still need 6 of them. How wide was Ron's figure? 2. So we go back 2 dots again. That's a little different. I got to do this one also. Okay. So watch me, kids, before you connect the middle. Are you watching? Sometimes kids do this. That's wrong.
How would it look if you do that?
Not right. So make sure you go down on the last one. Okay? So this is length times width times height. Go ahead and get it labeled. No, you were going diagonal up the paper instead of down the paper. It's okay. All right, so tomorrow we will work on the problem set and answer questions involving these things we've learned today. Okay?